Right, so we're going to have a quick look at how to use this Metrel MI 3152 multifunctional tester to do a couple of tests on this rig here. So this is a consumer unit setup. This is a sort of a 2006-2007 type setup that you would normally come across in some of the older flats. This has half RCD and then half non-RCD, so I wanted to fit a board like that on this rig so you get a bit of both really to do your normal testing. So fairly simple installation. We've got the supply coming in. Assume that's your main intake cutout, main fuse. The power goes into the tail, into the meter, and then from the meter you've got the live and neutral coming into the main switch. The earth from the incoming goes into the MET, and then once the power supply comes in, then it goes through the bus bar here for the non-RCD side, and then the RCD side will be in here, which is generally for the socket. So it used to be that the lights, smoke detectors and some of the heating elements are on the non-RCD side back then, and then the sockets are on RCD side. That's how it used to be. So I kind of wired it that way. In here we have 3 circuits. We've got the ring circuit, which covers these sockets and a fuse spur. So it kind of goes that way through these 2 sockets, come down through the fuse spur and back into the board, and then that's that ring circuit, which has the 2 live wires, and then we got the 2 earth wires for it. And then we also have in the neutral section we got the RCD neutral bar and then the non-RCD neutral bar. So in the RCD neutral bar we've got the 2.5 neutral cables which are part of the ring mains, and then that's the earth for the cables here for the ring main. And then on the non-RCD side we got the 2 neutrals which correspond to these 2 earth wires in here, and then that's for 2 circuits on this breaker and this breaker here. They're both on 6 amp circuits. One is for the lighting circuit and then the other one is for the smoke alarm circuit. So in terms of the testing, what we're going to do is we're going to take a measurement of a ZE value, or the ZE or the ZSR distribution board. So that's the loop impedance value at the distribution board point if it's a sub dB, or then the ZE if it's connected to the main supply coming in. So we're going to measure that, and then after that we're going to do a continuity test. So we're going to do an end-to-end test on the ring main brown, and then I'm just going to show you on the brown. It's the same process for the neutral and for the earth. And then we would do a R1 R2 reading for the radial circuit, which is a lighting circuit. So we would take the earthing conductor, put that into the live earth bar in here, and then we go down to the end of the circuit, and then we take a reading there for the continuity of the R1 R2 reading. And then we could do a loop impedance value reading from end of the furthest point socket, and then we would also do a RCD trip test, and I think that's it really. So let's get to it. So just to quickly show you the accessories that come with the unit. So we got this lead that goes in here, and to charge the unit you slide it that way, and then you plug in the charger, which is in this pouch in there, and after your charging is finished you get this wire, plug this in here. So it comes with 2 sets. You got this set in here, and also it has this set with the plug which has that interface there. That's for like taking a status reading of the socket outlet. So let's have a look. Now we plug this one in here, and then in here we got this what they call a tip commander, which has some controls when you have this in your one hand and then the other probe in the other hand. And if you don't have a hand left to press any buttons in here, you could literally use the controls in here, but that's been disabled at the moment, so you would have to press that button. We would now just quickly go through the content of this. So we got this the tip commander, we got the earth wire, which you can change between the probe and then the crocodile clip, and the same for the neutral wire, which got the croc clip and then the probe. So when you're taking a 2-wire reading, for example a high current SEDI, a high current SEDES, or a SEDES, or a SEDES from a circuit which is not an RCD. If it's not on an RCD, then you can use a 2-wire test to take a high current reading. If it's protected by an RCD, then you're going to need to use live, neutral and earth. So what we're going to do first test is we're going to take a reading at the incoming position of the fuse board. So to do that, what we'll do, we will clip these 2 together. So you can clip the neutral and earth connectors together, and then we will put this one in here. That would go there, this will go here. We will turn the machine on and just increase the brightness a little bit. Okay, so you can increase the brightness, but then it runs down the battery very quickly. You want to make sure this is fully charged before you use. So we do that, we go into RUS, and then the password, I'll give that to you. Right, so you put the password in, log it in, you go into single test, and then the items that you will vary between will be these three in here. R low is for continuity, this is for RCD, and that's for loop. So let's go into the loop. You click the loop there, you got the two settings in here. So if you're taking a reading using 3 wires, so using 3 wire, which is the live, neutral and earth, and that is for the circuits which are protected by an RCD, you will have to go for this option here. If you're using a 2-wire test, which is a high current test for circuits that are not on RCD, you will use this one in here. So in this case, I'm going to use the high current because I'm going to be taking a reading of a circuit which is not on an RCD. So take that, and then let's have a look. Right, I'm going to plug it in my lead to the extension lead. Okay, now the extension lead is plugged into a non-RCD protected circuit, and you can see the meter has powered up and you got the reading there. Now what we're going to do is we're going to put this probe in here. Be very careful, make sure that there's no any damages to the probe. Check the leads. If there's a little scrape or anything, they can short circuit, and you're going to be putting this into the main switch, which will just blow straight away the incoming fuse if there's a short, because there's no any protection at this point. So you can see I have positioned my actually, you know what, to be on the safe side, I'll go into a top of a non-RCD protected circuit breaker. So I'll put this one in here, and then I would put the earth wire into there. So I've got these two. Now I'm going to have a look at the reading coming in. Nothing at the moment because the main switch is off. So let me turn the main switch back on. Right, so I've flicked the main switch on, and I've got wire on top of a non-RCD protected MCB, and then this on the earth lead. So at this point, I should, if I turn the breaker on, flick the breaker on, okay, breaker's on, and I'm going to put this one in here and that one there. So I should get a reading here indicating between live and neutral, which is the bottom line, is 236, and between live and PE, which is the top left line, it's 237. So it's ready to take the reading, and I've got the green line in here. So I'm going to press the run button there. So that would now go through, and then it will come back with the reading to tell me. So that's it. So this is 1.54 ohms and 149. Obviously it's a lot higher compared to what you would normally get at the main incoming position. This is because it's on an extension rail which is plugged into a socket which is quite far from the main fuse box, so hence why you get a much higher reading there. But generally inside a house you would normally get a lot lower reading, something around about 0.20 to 0.30. That's what you would normally get in a domestic installation. So that's at the fuse board position and the supply incoming position to the fuse board. Okay, so now so that's how you take a SEDI reading, SEDES reading at the distribution board. And let's say you want to take a SEDES reading on a non-RCD protected circuit at the furthest point. So I think that lighting circuit would be that. So we'll leave it on the same setting. We would turn the circuit on. Let me just turn the light on. Okay, so the circuit that energizes the lighting circuit. I can see that the lights are on. So what we'll do, Ollie, can you do me a favor? When I tell you, can you press that button there for me? Right, so we will take that probe here. Actually, let's turn the light on. So that's the furthest point in my lighting circuit. I'm going to go into the earth, and I'm going to go into one of the live conductors. So this is now, you can see it's on. Actually, you know what, it's alright, let me do that. I'll press the button, it's going to run through and then come back to me with a reading there, 1.61. So you could do that, a 2-wire test, and get a SEDES reading there only because that lighting circuit was not on an RCD. Now if it was on an RCD and if I try to do it with the 2 wires, it will trip. So always remember, 2-wire high current or high loop test over there is only for circuits which are not RCD protected. If it's RCD protected, you have to use 3 wires. They're going to have to disconnect these, put the neutral, earth and live. Okay, so that's what you got to do. Right, so that's the said S reading at the end of a circuit. I could do the same thing in here. I can go between earth and live. So that will be my ZS reading for that circuit. Now let's do a what we will do a continuity test. Right, so I'm going to do an R1 R2 test, and what I've done is that I'm going to put a croc clip into one of these, which is going to be there. Let me get this one back in. So I will remove this from here and I will change that to a croc clip, which would go back in here. Right, so that's a croc clip in, and what we're going to do now is we would connect that in here. Actually, if you're at the board, first thing you have to do is, what I've done is I've taken out that lighting circuit that was in the breaker, make sure everything's off, and then I'm going to put this into the earth bar here. Some people use a little fly lead or a Vago connector, whatever, however, just to get a link between this wire and that wire. So if you want to twist it and link it from one side, when we link it like this, this would now create a closed circuit. So if I send a signal from here, it will go down the earth wire into the board and then jump into the live wire, and it'll come back in here. That would enable me to get a reading. Okay, so what I will do, I will click this one in here to the earth. Oh, okay, so that's there, and in these settings I will now go back into click the return button here, return button there, and then go into R low, and then we go into R200 and leave it there. So Ollie, yeah, I need your help. So I'm going to put this one in here into the live conductor, and then we'll leave that there, so it's on a live and earth. Right, can you press the button here? And oh, no, this man running button.
Yes.
Yeah.
Hold it?
Yeah. Let it go. So it's running through. You just need to press it once. This is 0.26. So that's my R1 R2 value for the lighting circuit. Yeah. So just to run through steps again, you would take the live wire, put it in the earth bar. You go into the end of the circuit, put that across. Okay. So let me remove this one and put it back in. Okay, right, so I need to hurry with this video. I've got something else to sort out quickly, so I'm going to quickly run through what you need to do to get the readings, but I wouldn't show you how to do it. I wouldn't go through with the meter to run through the whole process. So basically now we're going to, if you want to do an end-to-end test, you would take out the live wire out, and then you put a croc clip, use that croc clip, and then you can also put a brown croc clip you can clip onto this. So you'll have a croc clip on this and a croc clip on that. You will put that into, you take these 2 wires out, put one into here, put one into there, and then same thing again, you go into R200. Don't worry about this ring continuity thing, and then you press that, press the enter. That would give you the end-to-end value on this. You do the same for the neutral, and then you can do the same for the earth. On a 2.5 ring circuit, you would get a slightly 1.5 times higher reading on the earthing wires than the ones you get from the live and neutral, because the conductor size is smaller. So that's how we do the ring continuity. And then in order to do the RCD test, you would you can do it from a socket, or you can do it at the board as well, whichever way. If you're doing it from a socket, just put the socket interface, plug in here, make sure the switch is on, RCD is on, everything's on, and then you would go into the tester. You would use the RCD, and then you put RCD time. We're only doing a ×1 test, so check if your RCD is a type A or type AC. So this RCD only has 1 wave, that means it's type AC. So we're going to change that from here. We're going to go into second line in here and change that to AC. This is quite an expensive machine, so it can do like type B as well, which are for DC circuits for like EV chargers and things. So it's on AC, 30 milliamps ×1. We're not doing ×5. And you get that setting, then you plug it in, you press test, it will then trip the RCD and give the reading, and that reading should be less than 300 milliseconds. If you want to do this at the board, you could put your turn the circuit on, put live here, earth here, neutral on the RCD protected neutral side, press test, and we'll do the same thing and it will trip. So that's how you take the RCD reading. Insulation resistance, if you decide to do it, the way to do it is you go into ISO and then ISO, and what you do is that you get the two, make sure the board is off completely, and you will connect the earth to earth and then put this into one of your circuits. Make sure everything is unplugged, all disconnected, no loads whatsoever, nothing at all, and then you would turn the circuit, leave the circuit breaker off, and you can just press enter. So that would do 250 voltage, and it will run through, and then it'll come back and it says greater than 200, and that's pretty much it really. So that's the whole process. Just run through it again. If any questions, come back to me.